Great. Now, thank you very much, Dave. Can't believe I got these slips all over the place. Remind me to do it. I got to come up with a better process. I guess it's I got to mistake proof it. That's what I have. Pokey. I've got to come up with a with a method. Well, let's see. Let me answer this. Okay. All right. Hey, no questions, comments, or anything? Okay. So, what? So today we're going to do the presentations as I talked about last time, and we'll just go through with. So, so what I'm expecting to see tonight is the from assignment team assignment 4.4, the theory of constraints for your MVP, and basically your assignment 4.4 and the value stream maps are your will be the presentations will be your presentation tonight. So what I did was I went ahead and downloaded all the assignments, and that way we don't have to go through the portal or anything like that. And as you give your presentation, I can go ahead and flip the PowerPoints for you. One or two teams for the value stream map actually I guess included it in your overall project, your project slide deck. So what we'll do there is I don't want to go do a whole project presentation tonight. I just want to see that part of your presentation that deals with the value stream map. So in that case, I'll just flip through the slide deck and get to the appropriate value stream map, and then you can discuss it. So everybody clear on that? Okay.
Yes, sir.
All right. So what team would like the high honor and privilege of going first?
Variation can go first.
Variation. Okay. So I'm going to do, I've got two files here, the theory of constraint file and the value stream file. So we'll go ahead and do the theory of constraint one first, and then we'll pull up the value stream one. Okay?
Okay.
All righty. Let's see here. Let me put in. Okay, everybody see it okay?
Yep.
Okay, fire away.
This is Ron. I'm gonna start the presentations, kind of the comparison of the Toyota production system and the theory of constraints. Next slide. Essentially, the Toyota production system, we'll start out with that, organizes manufacturing and basically logistics and interaction with suppliers and customers. It is a precursor to lean manufacturing with the main goal to remove inconsistency, overburden, and waste from the process, the process as a whole. The use of Toyota Way, it's essentially 14 principles that underlie the managerial approach. They could be put into 4 sections: long-term philosophy, right process will yield the right outcomes, people development, and of course continuous improvement. Next slide. I'll start giving a brief kind of like explanations of each one. So we'll start with long-term philosophy. This is essentially when base management decisions for the long term are made even at the expense of short-term goals. This is essentially the first step in the Toyota way. The next section, which we were talking about, was the right process where you yield the right outcomes, is essentially numbers 2 through 8. They're all, like I said, all in the right process where you yield the right outcomes. This essentially creates a continuous kind of flow to bring problems to the surface. Uses pull systems to avoid overproduction. They level the workload to minimize waste and not to overburden people or machines. Also, the concept of quality and station. So essentially, building culture of taking time to fix the problems and get the quality of the products right the first time. I'm sorry. Standardized tasks for continuous improvement. These steps also use visual controls so the problems aren't hidden. For example, 5X. We've all heard of that. And also, for this section, last but not least, use reliable technologies to serve the people. So kind of hits home the right tool for the right job. The next section, which was people development, which are essentially the number 9 through 11. They're all, like I said, deal with people development. First one is to grow leaders who not only understand the work, but kind of live the philosophies and teach these philosophies to others. Next is develop people and teams that follow the company's philosophies. You want people to be on board with what we're doing and kind of head in the similar direction. And last for this section, respect the external network of partners and suppliers and help them become stronger. Essentially, you want your external people, which are part of your business, to also grow with you. And you know, without them, you're kind of like dead in the water too. The last section we covered was the continuous improvement section, which is the last 3 there, so 12 through 14. Basically, go on the floor. It's the whole Gemba thing where you go on the floor and see for yourself, do thorough understanding of the problems. The next section is take the time to get buy-in. So make your decision thoroughly, considering all the options, and get consensus from all the groups that are involved. And the last one, 14th, reflect and improve. Becoming a lean organization that looks upon itself and always strive to improve. So you always want to reflect on how you're doing and basically continuously improve, if you will, by reflecting on where you've been and where you want to be. Next slide, please. So switching gears, here's the theory of constraints. Theory of constraints is it views any manageable system as being limited by a small number of constraints within the system. Sort of kind of thinking of the old saying, you know, chain is no stronger than its weakest link. A constraint is anything that prevents the system from achieving its goal. For example, equipment, people, or even policies themselves. They could all be constraints. Theory of constraints is the concept that organizations can be measured and controlled by 3 things essentially: throughput, operational expense, and inventory. The main theory can be thought of as only by increasing the flow through these constraints can the overall throughput be increased. So this can be done by focusing on these 5 steps. I think that's all I have. I think next slide, and I think Danielle can come and finish it up.
Yeah, I'm here. Okay, so here on the comparison values, one of the things we had on here, both TOC and Lean value the principle that is the customer's perception. So Lean's perspective is that the value can only be defined by the ultimately by the customer. For TOC, the customer's perception of value is a major determining factor in increasing a product's throughput. So with TOC and Lean, the focus is on the customer's perception of value. The value stream, whether called value stream or Lean or value-added Lean by TOC, the concept is the same, which is a clear acknowledgement that the customer value is created by a chain that extends far outside the walls of the manufacturing plant. Both methods also recognize that job of every person within the organization to turn inventory into throughput. For inventory, TOC's perspective on inventory is that the purpose of inventory is to protect throughput, which is the bottom line. So under some circumstances, it makes sense to maintain a buffer inventory to protect against variation in upstream processes. This inventory makes up the buffer portion of the drum buffer approach to your synchronous flow. Lean takes a somewhat less generous view towards buffer inventory, considering all inventory waste. So both philosophies promote reducing the variability that makes buffer inventories necessary in the first place. So one major difference is that TOC will leave the buffer in place until the variability is reduced. The pull system for both TOC and Lean embrace pull and offers techniques to control the flow of the product based on the pull from the market. So Lean approaches the pull concept sequentially, meaning there's no one upstream should produce a good or service until the customer downstream asks for it. So pull's the driving force between TOC's buffer drum rope approach as the market demands, and provides the basis for scheduling the constraint or drum, which is the basis for releasing any material in the manufacturing process. The advertised objective of improving efforts is one of the major differences in TOC and Lean. So as in this area, Lean and TOC have completely different obsessions, which is reduced MUDA versus increased throughput. So I guess the summary here is TOC's concept of continuing improvement by focusing on and managing constraints may not be as inspiring as Lean's goal of seeking perfection. However, the complexity of modern organizations and systems leaves managers with an almost unlimited number of things to improve. The TOC's constraint force approach is both logical and practical. Identifying and addressing constraints provides the fastest and lowest cost means for increasing the throughput of any organization. Meanwhile, Lean offers a different approach to improvement, that of trimming the organizational fat, so to speak, by removing waste at every turn. And this is the last slide, and that concludes our presentation.
All right. So anybody have any questions for team variation? So looking at the two, just one question, just looking at the two different systems, and anybody on the team can answer this, or you can all answer it. Do you favor one over the other as far as within applying it to your either to the project or to your specific organization? Which one do you favor, one or the other, or a combination of both? What are your thoughts?
Well, my personal thought is I always tend to prefer the Toyota way, just because those 14 steps are just clear and easier to grasp with people. And so when you try to get buy-in, the TOC is just a hard concept to grasp sometimes. Though I understand it's hard to portray, and I usually find Toyota way is a good initial, and then when you get those things going, do you go to the latter, in my opinion.
Okay, all right. Anybody else from the team?
I'd also have to agree with Ron. I think TPS is kind of, it's a very throughput process as far as the steps. It's easy to understand. So I'd have to agree with Ron there.
Okay. All right. All right, good. So let me go turn over. So let's pull up now. I'll close this one out, and we'll pull up your value stream map, and you can briefly go over that. Okay, was this it?
Yeah, that's a value stream map. It's really hard to see in this application.
Yeah, let me do one thing. Yeah, let me.
I have it in Excel. If you want to give me presentation rights, I can show it in Excel.
Sure. Okay. Give me 1 second. We can do that. I'm sorry. Who?
Dave.
Oh, Dave. Oh, yeah. Will do. Okay, I think you should have it now.
Okay.
Let me,
The my so
yeah, let me see it. Let me do one thing though, because I've got to, shoot, hang on a second. Yeah, I don't think anybody else can see it because it's on the other, hang on a second. Any,
We can see it.
oh, you can see it? Oh, okay. All right, good.
all right.
Can you,
So
can you blow it up? Can you blow it up a little bit, or is that,
I can make it as big as we need
oh,
to.
okay. All right, go ahead. That's fine. Everybody can
So
see it, right? Yep.
all right.
Yes.
So we'll start at the back so everybody knows what's in the boxes. So I have like a key over here on the right hand side. So it gives you your totals for inventory wait time, cycle time, machine time, total value add time, lead time. So that's what's in the boxes. It adds it up for you. This spreadsheet does it automatically for you. And up in this top corner, it gives you put in your demand, units you need to put through a day, and then it gives you, puts out your tack time. So this spreadsheet I have actually has two sections to it. The second page of it, you actually put all your data into that. So on the second page is where you fill in all your operations, process operations, what op it is, how long it takes you. You fill all that into the spreadsheet on the second sheet, and it populates the front sheet for you. So in this one, when you go through our value stream, we started the supplier, and then the parts get to us. They get issued out of the stock room to a stamping operation. So each one of these boxes has how much time it takes in seconds, and then what the first pass yield is and the uptime. So depending on the equipment and the yield for that particular operation. So of course, this is a stockroom operation. You have 100% yield. You have 100% uptime. We'll get into the other ones. They depends on what it is. So the second one is stamping plates. So we have a stamping cell. It takes them so many seconds to stamp out plates. And then first pass yield, 97%, and then the uptime, 90%. So then we pass on to a cleaning process where they actually take the plates and clean them. And in that operation, it breaks down by the time it takes the operator, machine time, and first pass yield. There, we never have anything fall out in cleaning, so first pass yield's 100%. Uptime's 92% because cleaning in the cleaning room, we have to clean the tanks out and wash them every so often. So in that operation, we don't have 100% uptime. So as we keep processing through, we go to our welding station operation, and there again, we show the how long it takes to weld and first pass yield there. After the first set of welding for the ID, it has to go for lab approval in a metallurgical lab. The metallurgical lab takes time. Of course, they don't destroy anything, so 100% yield. We go on to OD welding in our process and leak checking. That each one of these is laid out the same, so you can see the seconds it takes for the op, for the machine, for the first pass yield. The next one is fixturing and unfixturing for the heat treat operation and the heat treat operation. So this gives you a pretty good cycle time as far as like machinery, right? Because in the heat treat operation, the parts have to go through a oven cycle, and there's actually time involved there. But most of the other ones, you don't have a machine time where the parts actually sit in a machine and they don't get touched by an operator. So here you actually have it broken down into all the sections. And this is future state, and this is where we have the most fallout with our program right now, and we're hoping to bring this heat treat operation so our first pass yield goes up to at least 94% for our future state. So after heat treating, it goes for lab approval again. And then that comes out, it goes to load testing, is where they check the spring loads on our cores. Then at the next operation, it goes to clean again. And then we, after we clean the details, we actually go and leak check all the components. Then it goes into a leak test with the assembly, with the top and the bottom welded on it. So the first leak check is checking the core portion of the part to make sure that there's no leaks in the individual convolutions. And then the second one is once they put the end plates on to make sure those welds are good also. After that, it goes to marking, lapping, and loads. So we mark the part with a laser marker. We lap the carbon on the lapping plate, and then we check loads and MEDs. So MEDs are just a an operation we do as part of the load check. So, and then after that, it just goes to inspection and packaging. And then it gets shipped out, and of course we ship it by truck, and then it goes to the customer. So pretty long flow chart there, but it encompasses all of our operations.
All right. Good. Questions? So now did you construct this spreadsheet from scratch, or was this a template or exported from another program?
So the spreadsheet's a template. I made the map itself, but it's actually a template, and actually on the third page, which I didn't show you guys, it has all the symbols. So you can go grab the symbols on the third page and just take them to the first page and drop them in here.
So for instance, so did you this was a template, or you actually constructed it manually?
So I constructed how many boxes are on it and all that.
You did all that, okay. And
right.
And then the data tab, that you also created that you created that also?
Yep.
Wow.
So this just comes with headers in it, so you have to fill everything else in. So because it doesn't know how many operations you have or locations or any of that stuff.
Yeah. So in other words, you didn't download this spreadsheet or this template from the web or anything. You basically did it by hand.
Yes.
That's really good. In fact, would you mind emailing me a copy of that?
No. Yeah, I'll send it to you. No problem.
Yeah, great. Yeah, because that's I thought at one point that it was that you used a program or an application for that, because there are applications. I think I told you all about digraphics, but that's quite good. And I'm sure that took you some time to do. I remember doing I remember doing my the first value stream map on for my Lean Six Sigma project, and it was I didn't use Excel. I think we used Word or something, and it was pretty painful. But yeah, please send me a copy of that. That's real good. All righty,
no problem.
Good job with that. Yeah, that's nice. So let me go ahead and see. Okay, and who would like to go next? How about Prime Aircraft? Hello? Anybody out there?
We're here, sir.
We're here.
Prime Aircraft? Okay. We'll do it same Same drill. We'll do theory of constraints first. So I'll go ahead and pull that up for you, and you can. Okay, fire away.
Good evening, all. This is
So,
the,
Hello?
yes, sir. This is Judith.
Oh, okay.
So this is our yes, sir. Myself and Megan who were talking over each other. So for our presentation, we will go over the Toyota production systems against the theory of constraints. Team members are myself, Jamie Yeo, Jake Carter, Matthew Fountain, Megan, and DeCarlo. Next, please. For the first slide, definitions of the Toyota production system. At first, looking at them, they seem to be polar opposite, yet at the same time somewhat similar. TOC is the concept describing the many constraints within an organization, their effects, and applicable solutions. Looking at principle 2 of the Toyota Way, all of the possible constraints were identified, and the following principles 3 and through 14, I believe, walk you through the process of resolving the constraints. So when you're looking at an automobile maker such as Toyota, I believe, and as a team, we believe that Toyota is the right organization because it can easily be measured by it being a made-to-order synchronized production system. Next slide, sir. When you're looking at the similarities of Toyota production systems and the theory of constraints, I wanted to highlight the key ones as I saw them, and how when we're looking at our own MVP. So looking at the similarities, the first one, we believe that both systems seek to establish a continual process flow to identify elements that hinder the flow. The next one that I wanted to highlight is the third one, where both use balancing of their workloads to smooth out the process. And both view excess capacity as a good thing, which definitely looking at diving deeper into the TOC and TPS, we could see this as a strong point, which we could definitely use as part of our MVP as well. And the last one that I wanted to highlight would be both can achieve immediate results, but require long-term effort to sustain the results. So pretty much looking at the TOC and TPS, I kind of related to our MVP, how they would fit and how it worked for the Toyota automobile maker. Next slide, sir. Thank you. Megan, do you want to take?
yeah. So some of the differences that we spotted between TOC and TPS, the TOC we said was a philosophy and a quality and methodology that the companies had put into practice, that they were using tools for quality management. The TPS was a quality system developed through practice by a company, and it was highly considered as a benchmark, so it was like the gold standard that other companies were seeking to do as well. The TOC was calls areas hindering process flow, such as the bottlenecks / constraints, and TPS was calling them pacemakers. They both seek to break these, but TOC was more willing to work with them to advance operations, whereas the Toyota production system refused to allow such constraints to dictate the pace of the operations. The culture and the traditions that drove the Toyota Production System forward to where it is now started long before a theory of constraints was ever formulated. And then the Toyota Production System, they always wanted to empower the organization and their employees and to take action. They always wanted to halt production immediately if a problem was spotted on the production line, instead of the theory of constraint, which they would rather improve communication and the correction of defects. Next slide. So some of the things that we said were for today, the theory of constraint, they asked some very important questions, such as, what is your goal? Are you meeting that goal? Why or why not? What are the constraints affecting your goal? And instead of thinking about them, a theory constraint practitioner would say, go, look, and see. And then a strong component for the Toyota Production System was the reduction of waste in the production process. For example, reducing the inventory or reducing repetitive actions that didn't contribute value. And according to Toyota, they have only reduced waste down to 50%. So they are also telling their employees the same thing, go, look, and see. And both of these theories consider it important to strive to be both proactive and to interact in their continuous improvement. And I think that's it for our slide.
Okay. Questions or comments, anybody? So did you, as far as your project goes, were you able to see any applications of, let's say, the theory of constraints in your that you might be able to apply to your project? Anybody can answer on the team.
Yes, sir. I think as I went through the similarities, and even from looking at what I definitely can see some things that we can apply to our MVP, because when you're looking at reduce waste, excess capacity, I like the excess capacity as a good thing, because if we had that within our the issues that we're trying to resolve with maintenance and parts, and I think if we had that as a turning point within the problem, we could really resolve the problem, because that's one of the things we don't have. We don't have excess parts. We don't have a lot of things that we should have on hand. And so applying this theory of constraints, I think, might benefit us. Some of the points there might benefit us.
How about with the Toyota Production System? How about with the Toyota Production System? Do you find any elements there that would really that you could see applying either to your project or maybe even somewhere else in your organization, maybe down the road?
Yes, sir, because the 14 declared principles that they have, I think, like the way they walk you through from identification of the problem and how you can, what you can apply to resolve it. I think, I mean, definitely my organization can find some value in it. And so will the MVP that we're working on right now.
Okay. All right. Anybody else? Okay. So let me pull up your value stream map. Close this. Value stream map. Okay. Ready whenever you are.
How you doing, sir? This is Jay.
Hey, Jay.
Okay, so we have already went over, this is our MVP, aircraft readiness and parts availability. So the value stream map is going to be showing. Next slide. Go to her.
All right, so you want me to go right? Let me go right to the value stream map. That it?
That is it.
Okay.
Okay, this is our current BSM. That starts with an aircraft braking. The aircraft brakes, the aircraft has to be status. That's a process we have to call into another unit, and they status the aircraft. That's information that goes military worldwide, so everybody knows what aircraft is broke. After an aircraft is broke, our maintainers go out and they troubleshoot, so they can identify if the part's really broke, why it's broke, how it's broke, and if we actually need to order a new part. When we have to order a part, the part has to be removed. After the part is removed, we order a new part. After the maintainers have done all the paperwork and everything that needs to be done, it goes to the supply unit. Supply unit is really the beginning of the ordering process. And at this point, we come to like a fork in the road, if you would. If we order the part, the supply has to decide or look up to see where the part is. And if it's in the Air Force or it's in the supply chain, it could be on base or another base could have it. And if not, it's a vendor asset. And if the vendors have it, we've got to contact the vendor directly, which is a long process. And if it's on base or in our supply chain, we just order the part. We order the part, and then the part issues. And on the vendor side, we've got to acquire funding for the part. Goes to the
Yeah, Jay, I think you're kind of fading in and out there a little bit.
On the vendor side, aircraft is fixed and ops check, aircraft good. Back home to the military side, after the part is shipped to the warehouse, has to be in process, and then they store it until they get to it. If we've got a high priority on that part, they've got 8 to 24 hours to deliver the part. That way the aircraft is still sitting for a while. After the part is delivered to the unit, we go to the unit, the maintainers go to the unit, pick up the part. Part signed for, parts installed onto the aircraft. Aircraft is ops checked, aircraft good. Okay, you can go to the next slide, our future state. Okay, it's systematically improving and eliminating constraints or bottlenecks in the process. So when identify the constraints, exploit the constraints, subordinate or synchronism of the constraints, elevate the performance of the constraints, repeating the process. Applying lean tools to the 5 focus steps, value stream mapping, use Kaizen, line control, and total productive maintenance. Okay, next slide. Okay, you want me to go over this, or are we just going to the slide?
Yeah, you can just go to the future state. That's fine. Yeah, that's fine.
Okay. You can see that it's basically the same process, but we identify some areas where we think we can cut time or make some changes. You can see in the process of the troubleshooting and remove parts, initially how it's done in the current state, they remove the part, they troubleshoot the part, remove it, and then order it. If we can cut the team in half, have some of the maintainers troubleshoot and remove the part, and 2 or 3 of them inside ordering the part at the same time. Another one of the constraints is the supply unit. They only have a 1-shift operation, and we need them to order the part. If we could get a 24-hour coverage with the supply, they could add 2 people That way they could cover all 3 shifts. That would cut the time significantly. Another problem, Kaizen area that we saw was the vendors. We don't have a POC or a person of contact in between us and the vendors. And it's a long process when we call the vendors because a lot of times they don't answer or they don't reply back. But if we had a POC, they would know who to contact exactly. And another part is when the part is delivered to the base, then it goes to the warehouse, and then the warehouse has to deliver it to the unit. We put a Kaizen there. The maintainers, when the part comes to the base, the maintainers could go to the warehouse and pick it up themselves. So you wouldn't have to worry about them processing it, putting it on the truck, and then bringing it to us. Okay. And down at the bottom, pick up the parts, same thing, cutting out the middleman. And that it is about it for that.
Okay. So these Kaizen bursts these would they be relatively would you be able to implement them pretty quickly, or are they potential or are they part of your project, or would they be spun off into another project?
Well, it's hard to tell with that. I've been talking to the champion, and he's not against it, but not so much for it because we deal with a lot of working pieces in our process.
Mm-hmm.
A lot of different units where we don't have no control over them.
Right.
They fall under a different command, different commander, like supply and the vendors. And that's where most of our problems are, is with the supply and the warehouse and the vendors.
Okay. So there's a lot, it sounds like there's a lot of variation there. All right, good. Any other questions or comments? All right, well, thanks, Prime Aircraft. And see, we'll go ahead and close this one. And who's going to be next?
It's going to be Cameron and myself for Team UTC.
It's only, how many, UTC. Hang on one second, let me see something real quick. Oh, you're the last team anyway. I don't know, I kept thinking it was 4 teams. Must be my other class. All right. Team UTC. Okay.
All right, good evening. My name is Edgar, and my teammate is Cameron Helland for Team UTC. If you want to go on to the next slide.
All right, good evening. So let's talk about the TPS, or the Toyota Production System. TPS, it focuses on 14 principles in 2 key areas. Those 2 key areas being continuous improvement and respect for their people. And they achieve this with continuous improvement, they create a long-term vision by setting goals and creating creativity through innovation and evolution. And they do this through the right process will produce the right results, and continuously solving root problems helps drive the organizational learning. So the more your employees know, the least likely that you'll have issues or defects out on the floor if they're willing, or if they're able to come up with a process that can do it right the first time. And so this transfers over to the respect for their people, developing respect for each other and promoting teamwork to achieve mutual trust and professional growth. And then, of course, adding value to the organization by developing your people. And you can see there at the bottom the 2 founders of the TPS system. Next slide, please.
Of course, like the other 2 teams talked about, the 14 principles. To our TPM, there's some of these, especially more so with the people aspect, is the one that would definitely apply to our MVP project. we already have a long-term philosophy within our company and have a continuous flow process and a pull system. There's been a level workload already within ours. One of the biggest issues is building of the culture, and we thought that that was extremely important because, of course, the more things are in sync, the easier things will run. And if it's kind of a bad culture, then of course the opposite will happen. Standardized work was one of the interesting ones that we looked at because standardized work can kind of depend from the perspective of those who set the standard work. And one of the things is with respect to the people, you have to be able to tie that into not only the work, but also think about the other people's ethnicities, cultural backgrounds, because what something will mean to one person will not mean exactly the same thing to another because of the diverse culture that one may have. Visual controls, reliable tools, kind of go hand in hand. Growing leaders is definitely one of the musts. And it goes along with developing your people, as well as respecting and growing, especially with your suppliers, because of course, again, if things aren't in sync, then you will be behind. The go and see mentality, we kind of saw the plan, do, check, and act aspect as well to that. Thought out decisions, and we kind of brainstormed in that. That was more to do so with having a good plan in hand, and of course, continuous learning, thereby developing and growing those people to become a more reliable source for your operation. Next slide.
So for the theory of constraints, the theory of constraints, it's a methodology used for identifying the most important limiting factor that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer that limiting factor. It's a scientific approach for improving bottlenecks within a process. So fixing the weakest link, because you can only go as fast as your weakest link. And then a highly focused methodology and rapid improvement. Top priority is the current constraint. So looking at the 5 steps of TOC, step 1 being identifying, of course, the constraint, and then 2 being deciding how to exploit that constraint and go about to fix it, and then step 3, subordinate everything else to the decision in step 2. So making that constraint your top priority, fixing that, and not trying to fix multiple things at once. Step 4 would be evaluate the constraint, and then of course 5 would be go back to step 1 to avoid inertia and allowing it to happen, continue to happen again. Next slide.
So theory of constraints definitely has some benefits, or it has definite benefits, of course. You can read those there. Our business actually uses the drum buffer rope method, which is one of the interesting ones because we didn't really kind of understand it at first. And after looking at it, it kind of made sense, especially when we got to visualize it within our own organization, specifically within the cells that Cameron and I work in. So the drum being the constraint is actually kind of the pacemaker. The buffer is the inventory needed to maintain consistent production. And of course, the rope is kind of like the visual signifier indicating that things should go on. And so we have certain visuals in our area. There's actually schedules that are set out, and we have an established takt time within our cells, well, at least within one specific cell that we're working. And that's how is the highest producing of any of the others because there is such a high demand for it. And so this was definitely one of those terms that really, well, the terms drum buffer rope. It was kind of neat to actually visually see it instead of just reading it by what it said on the book. Next slide.
All right, so looking at some of the similarities between TPS and TOC. So both of them focus on the continuous improvement aspect, and they both strive to identify bottlenecks and then to eventually eliminate them. And both are designed to create a pool type flow system in the production by, both through separate means, of course, but both want to develop that pull as opposed to that push method. Next slide.
We kind of saw a lot more of the differences. The biggest one kind of differentiating between both of them was that the Toyota production system heavily relies on people. Now, theory constraints can go at a more deeper level into a specific aspect within a process. However, it can also apply to a person, if I'm not mistaken. Sort of in thinking that maybe there's a person is a constraint because whether it be knowledge or education within the process, which in turn affects the process itself. And so it's just both systems kind of tell the same story, just with different words. Because there's for throughput, inventory, and operating expenses, it's pretty much kind of the same for cost, lead time, and value and non-value added. The measures are kind of the same. I mean, there's cost to throughput and inventory, and of course operating expenses. Lead time kind of has to do more with throughput and inventory, and so a lot of these things just kind of mesh together with one another. But again, it's just kind of more, we thought a little bit of the verbiage, telling the same story just in a different manner. And again, the biggest focus, the biggest change, the biggest difference is that I personally thought was just the focus, where theory constraint is more on the process or specific aspect of it, and the Toyota production system has to do more with people working the process.
Still there?
Yeah, you can go to the next.
Okay.
That's the last one.
Oh, okay. All right. That's it. Okay. So, any questions or comments from anybody else in the class? So you said you're actually use a drum buffer rope at UTC?
Yeah, for the most part, there's depending on the flow of the product. There has been time where leadership has decided that they want to create a buffer in order to maintain the pace going. And so it just kind of depends on how the actual flow is going within our process.
So, go ahead.
We're supposed to be a one-piece flow. However, they kind of change it varying on whatever is going on at the time.
Right, to meet whatever the needs are. So did you actually know at the time, I mean, before you took this course, did you know that what you were doing in your, that the drum buffer rope was something that was came from the theory of constraints, or was this something that, hey, that you already, that you didn't know it was a theory of constraints, but as a result of this course, you got like an aha moment, hey, we're actually using this, or did you actually know that about the theory of constraints before this course?
Well, speaking for myself, this is all brand new to me. So this is the first time that I'm actually learning a lot of these tools and the terminology. I think it might be different for Cameron, though.
For me, I never heard of the drum buffer rope rule. Though it makes total sense in our process, especially when it deals with cure time. Of course, because currently we have a 4-hour cure time on our paint. So, of course, management and leadership tries to develop that buffer within so it doesn't affect our production and we don't have operators and quality standing around waiting for units to come off of cure time. So they definitely try to make sure that there's enough work in progress so that it doesn't affect our daily production. so learning about theory of constraints and learning about that really kind of made me go, oh wow, we deal with this literally every day.
Okay, yeah. So basically, you're kind of doing it, but you never knew what the what the actual theory was. All right. So I mean, that's kind of so that's where the theory and practice comes in. So it's something you're already practicing, but now you know kind of the theory and the why behind it. Is that a fair statement?
I think
Yes,
so,
sir.
yeah.
Yeah, and that's the thing about a benefit of higher education, so to speak. A lot of us know the what, but with the educational component, you get to learn a little bit about the why. So that's good. I'm glad that at least you can actually you can now you know the theory behind it, and then sometimes knowing the theory behind it, you may be able to even add additional input or make even some some improvements. So all right, good. All right, so let's turn to your value stream map. I'll pull that. Let me close this out. Value stream map. Okay.
All right, so this is our value stream map. I apologize now if you can't really read the handwriting. I don't have the best of handwriting. But so starting with, of course, the production planner, they're the ones that produce the production orders, which then get sent and order the parts, which supplies the stock room with all the resources they need to supply the floor. So of course, stockroom will supply the floor, starting at the first station, which would be hardware, and that's where, as Edgar and I are quality inspectors, we have to verify a lot of the serial numbers on the parts that are issued to that PO are accurate, and then of course once the operators install those parts, we have to verify them torquing the parts to the right torque value, and then we also verify some other documentation, so our COCs, which is our certificate of conformances, and then we also verify that because a lot of our inflatables are built over at another location in India, so we have to verify that there's certain tests that they did on the inflatables before we're allowed to let it move forward. And then so moving on to the second station, which would be FT, or functional deployment. So a functional test, of course, we do the deployment. We verify that everything, the deployment was successful. The lights worked, so forth. We have to enter some data into the computer, and then we do a lot of it's more visual inspection, make sure that there isn't any tears or broken parts, or there wasn't any packing errors, and everything came out fine. But there is some data entry that we have to do. We have to upload because we video every deployment, so we have to upload the video as well. And moving on from there, we have our squawk and paint, which is, so after the unit does get deployed, there is some touch-up paints that need to be applied to the slide surface, as well as if there's any patches that got loose that they need to be re-cemented down, or certain barcodes we have to glue on to certain spots on the slide, so we have to verify that that is done correctly. And then moving on to OK to pack, it's just another visual of making sure that all the correct stenciling has been applied to the evacuation slide, as well as we do a battery test and a light test to make sure that all the lights still work and that the battery's still good. And from there, it moves to the final pack, where the operator will pack it back up, and we have to verify that the bottle that gets installed to it is torqued to the right value, that certain dimensions are in the right tolerances. So there's a few checks that we have to do there. And then moving to the final inspection, this is mainly all paperwork. This is where a lot of it's just traceability and re-identifying stuff. So of course we check the documentation for accuracy and traceability. There's certain forms that we have to print out that we keep for our records as well as for the customer's records. And this is where, you know, this is kind of the catch-all. If there's any mistakes prior, this is where they all get caught. So this is a very important step in the process. And then from there, the COC sign off and shipping. So like I mentioned before, the COC is the certificate of conformity, which shipping will provide the inspector at that station daily with what units are going to get shipped out that day to the customer. So the inspector then has to collect the paperwork for those finalized units, and then just kind of do a quick check again to make sure that everything is there, sign off on them, date them. We have to make multiple copies, both for the customer and ourselves. And then we have to eventually then bring it up to the front office to scan it into our system. So it can take some time. But as you can see there, so the total production lead time is just under 6 hours. So it's 5 hours, 45 minutes. And then the actual value added time for us is 2 hours and 5 minutes. And if you can see it, we have there's but 6 Kaizen bursts that we added into the future state map. Since we are quality, we are a support function, we don't have a lot of control over the production flow other than our inspection points. So there's not a whole lot we can do for production other than paperwork. Next slide, which Edgar will talk about.
So the Kaizen burst that we have on our map, there's 4 Kaizens that are more realistic. There's 2 of them that are potential things that have been discussed before but never really completely signed off or waived off. So our first Kaizen would be our actual form layout. This is the CN form is our traveler that goes with the unit. As Cameron was indicating, ours is more of a, we're looking at the traveler along with the quality process, not so much the production process itself, but more specifically the form, the traveler that goes with it. And then there is another thing that came up today, but that's another thing aside. So realigning the CN form, redesigning it, making it easier to read, removing specific parts, holding our production more accountable for their steps, and having quality really there more for the really important inspections instead of having a lot of inspections that might not really have to do specifically with quality. So the form is definitely one of our biggest opportunities because our biggest contributors to our FPY being low, and not only in our cell but in other cells, is majorly because of the paperwork, because of missing information, missing sign-offs, QA stamps, incorrect information. And so recreating the form to be a lot more, to be easier to read, and educating everybody on what is actually supposed to be on the form and why that is important would hopefully minimize a lot of those rejections. Quality dashboard is essentially just a one-point location for a lot of the things that we use on a daily basis. Our champion had indicated that he kind of wanted a 1 or 2 click sort of system where instead of having to track forms through various folders in the system or in the network, you could easily access them rapidly, and everybody knows where the location of those folders are just by using the system alone. We're also looking to integrate some other functions to that dashboard that will help ease the qualities, kind of like the processes that quality has to do, more so some of the data entry, and that's these are actually the following too. So automated QN process is a quality notification. Is pretty much when a unit fails against it fails to meet the acceptance test procedure set by both the customer and our buyer organization, or when something is out of spec with any of the drawings or documentation related to the unit. And so a lot of quality people either don't know or have a really robust knowledge of how the QM process works or how to create one. And so we think that not only that, it actually takes some time also to do. Even the faster people within our department, it takes roughly maybe about anywhere from 8 to 10 minutes, while other people can easily take up to 20. Our system is actually looking to bring that down to under 5 minutes. And there's actually some areas that would highly benefit from that because they have a large amount of quality notifications that they create throughout the day. The last one for a more realistic Kaizen event would be an automated data entry and print format. Because like Cameron was saying before, one of our last station is the one that has to put all the paperwork together and make sure that everything matches and that there's no issues with it. And so one of the things that's caused the problem is the person aspect, the human error factor, where people have typed up the wrong thing, and some people have different ways of pretty much doing the same step. So I might do the process one way, Cameron might do it slightly different, another QC might do it differently, and so on and so forth. And so having an automated one would ease that and would actually eliminate a lot of that human error. For our potential events, these are two things that have been talked about before. They're not as realistic because there are other things that have to come into play for these. When we say 1 FT out of every 10 units, currently we deploy and test every single unit that comes into our process. Like Cameron said, we have data on them, we record them for data tracking purposes and for historical reference. There are our current process, our current cell is 737, like I said, had the highest output. We do 11 units a day, which is pretty much almost double what all the other cells combined are doing. So there's 3 other cells and ours produces the most. And so cutting that down kind of would help with that buffer drum buffer rope thing that we were talking about earlier, as well as the 2-hour cure time that Cameron had, or the cure time that Cameron had indicated that would also cause that came into the drum buffer or rope aspect. So he said our current cure time is 4 hours, and if we could cut it down to 2, that would further speed our longer process. However, like I said, there would be a lot of other parties involved to determine if there even is a possibility or would it be a viable Kaizen for us to have. Sorry for speaking so long.
Okay. All right, good. Yeah, good job there. What I would, is that the end?
Yeah, these are just some of the process measure metrics that are kept for us.
Okay. One recommendation I would make, since the value stream map is going to be part of your slide deck, I would put it into an electronic format. Maybe Team Variation will lend you their template, but whatever. Please put it into a electronic format for your final slide deck.
Will do.
Because you're going to present it, and like you even mentioned, the bursts are a little bit hard to read. So, and the reason for doing it, the reason we did it in handwriting in the first place is a lot of times in a in a situation in the field, you may not have, you may have to do a value stream map on the fly, and you may not have access to any equipment, or you're working in a room with a bunch of people, and sometimes it's just easy to write it out. So anyhow, yeah, it's just it's a good map. Just get it into electronic format. All righty. Any other comments, questions? All right. Good deal. So now we'll go to that. We'll go to the our lesson for the week, lesson 5. So we talk about Pokey. One nice thing about this class, if you increase your Japanese vocabulary by 100%, since most people have a very limited range. So anyhow, so Poka-yoke system approaches are utilized in manufacturing with the goal of having a zero defect systems. It's basically a control approach, and it may be something that you might be incorporating in your control plan when you get to that point in your project. So basically, it shuts down the process when an error occurs. It keeps the suspect part in place when an operation is incomplete. It gives you the warning, and it signals the operator to stop the process and correct the problem. Because generally speaking, it's a lot cheaper to correct a problem internally than having it leave the plant, go to the customer, and then having to deal with a unhappy customer. And as you'll see in a few minutes, the cost of rectifying the situation when it's left the plant and gone to the customer is considerably higher. So, an error, cause of defect. So these are 10 most common errors that we find, both in service industry and in manufacturing. Processing omissions certainly could happen in a factory. Part doesn't go in, or in an accounting operation, possibly a report's not run properly, or an accounting error. Transaction is not recorded when it should be. Processing errors, obviously, that can happen in both areas. Error in setting up the equipment, we think of in manufacturing, but even in IT, maybe setting up a server incorrectly, or not configuring a workstation properly, missing parts, wrong part, inclusion of a wrong part or item, wrong piece of equipment, operations, or a better word would be an operator error, human error, measurement errors, especially if you have a very low tolerance, equipment maintenance errors. Once again, pretty obvious in manufacturing, but even in IT, for instance, if the computers aren't maintained, or updates aren't patched onto the systems properly, and actually that might lead to even security issues. So that even applying a security patch to a computer, that's really a form of, in my opinion, a form of equipment maintenance. And certainly, if it's not done, the results can be disastrous. And of course, handling error. So this is the 1-100 rule, and so this is the 1-10-100 rule, and it basically says that a product or service moves through the production system, the cost of correcting an error multiplies by 10. So, if the order is entered correctly, which obviously we want to do, it's $1. If it's detected in billing, and it's $10. And as I just mentioned before, once it gets out to the customer, all of a sudden it's a factor of 10. It's now $100. And then, of course, we all know dissatisfied customers share their experience with others. And in the world of social media, it can get out there. It can get out pretty fast through all the different social media challenges. And you guys, you haven't taken the lean accounting course yet. Is that correct?
Correct.
Yeah, because you're going to see something similar to this, where you've got it's basically deals with appraisal, internal failures, and external failures, and there it's also a factor of 10. Where if you present and this is something you'll learn in that course. So this is so keep this 1-10-100 rule in the back of your mind, because they actually. In lean accounting, if it's an external failure, and they define an external failure as that it actually reached the customer, and the customer detected the error, they actually say that the cost is really would be another factor of 10, which would be $1,000. So anyway, you'll see that in your lean accounting class. But basically, So if you can, the takeaway here is obviously not to make the error in the first place, but if it is made, to catch it internally before it reaches the customer. Yeah, so in the bad old days, maybe it's probably still going on, I would imagine. The old way of dealing with human error was to scold, retrain them, and tell them to be more careful. But a lot of times it may not even be the human so much; it might even be the systems. If that would be something that Edward Deming postulated. So, what is your organization's attitude about human error? The negative part, if defects are inevitable, it's going to happen. People make mistakes. Then of course you got the old blame game. You wait. The defect is not caught until the final inspection, or even worse, it leaves the plant and is discovered by the customer. You've got sampling inspection. So in other words, if you have kind of a negative attitude about human error, you're going to probably set up a lot more. There's a lack of trust, and you'll have probably a lack of trust, and also a lack of accountability, and not giving employees empowerment. So you set up all these additional inspections because you really can't trust the frontline workers. And like I said, reaching the customer is the most expensive to correct. And in a positive environment where the attitude is, hey, we can eliminate it, you have an environment that promotes mistake proofing, and yes, the 5 whys to get to the root cause of the error. In a negative situation, people blame each other, but nobody ever looks at the root cause. Okay, it's just they paper it over and it keeps going and going, and I've seen a lot of that in my careers. But you try to find out the root cause, so maybe it can be eliminated, and certainly one of the tools of the 5 whys, and of course using good mistake proofing methodologies to prevent errors. So we're all human, and we all make errors. So errors that probably all of us have made at one time or another, including forgetfulness, not concentrating, jumping to conclusions. That happens a lot, especially when there's sometimes that's part of the blame game, looking to blame somebody on some kind of a defect. Errors in identification, errors made because the workers were untrained, people ignoring rules, inadvertent errors due to distraction, fatigue, slowness, lack of standards, written and visual, machine errors, and intentional errors. Hopefully, that's the least common. So the 2 states of defect, state 1 is prediction prevention, and that's the one you really want to, that's the cheapest one to be able to correct. Usually a warning signal, there's a control mechanism in place that provides feedback, and to avoid mistake or reaction plan. And generally speaking, no defect occurs, but if it does occur, it's going to be caught right at the beginning of the process. The other state is detection, where the error has occurred, it's detected, there's a warning signal, a control feedback, and then shut down. And you all know from reading about the Toyota production system, anybody on the on the production line has the ability to shut the line down if they see something has gone amiss. So, and those are really those. So having an effective signaling system prevents errors from going out the door and reaching the customer. So we have 7 steps for mistake proofing. First step is they describe the defect or potential defect rate, identify the operation where it can be, where it's discovered, detail the sequence of events documented in the standard, and watch the operation being done and detail the steps. It's kind of like the management by walking around. Identify error conditions that could be contributing to defect. So kind of being proactive, especially in step number 5. Identify a mistake-proof device that's required to prevent or come up with a way to prevent the error or defect by developing or identifying a mistake-proof device for signaling. And brainstorm if it doesn't work. Brainstorm a device. If it doesn't work, try again and mistake proof the mistake proof. And that might be in getting the frontline employees involved. Usually they're the ones that many cases have some, they may even have solutions in place that you don't even know about, but until you talk to the people and observe the process, you'll never find out about it. So some of them will probably have already developed some sort of mistake proofing system. It's just that it hadn't been discovered and it hadn't been documented. Anybody have any examples from their own world of work about mistake proofing signals or examples?
I always like to give the example of the microwave, where there's no way possible that you could, have the microwave on when you open the door.
Oh, okay, that's good. Yeah, that's good. How about in the aircraft industry? There's got to be some mistake proofing there. At least I hope there is.
There is. We've got checks and balances, 4 checks and balances.
Oh yeah, like examples.
We have what we call, like, if there's an inspection or a certain task that's done, we have what we call a 7 level, and it's usually a mid-level supervisor that'll go out and look at the work. Then after he goes out, then QA comes out and they look at the work. So we always check behind each other all the time, because like you said, it's always error for mistakes to be made.
Okay. Yeah, I would imagine. Yeah, especially in aircraft, that's critical. Anybody else?
We have the same thing at UTC in some of the cells. The QA will finalize the unit and all the paperwork, and then we have an over inspector that comes and looks over it to make sure that everything's good.
Okay. All right. Good. What's going on here? So these are just some examples of mistake proofing. Templates, sensors, counters. Good example really of mistake proofing is in computer program or even cell phone applications where you have a user interface and they'll like you might have like a text box and it has a drop down menu and you can only select from certain values. You can't type in your own value. So that might be an example of mistake proofing. In fact, a lot of times when they're developing applications, they'll have testers test the interface and try to break it. Okay, so when you're developing an interface for a program, whether it's a financial program or whatever, you've got controls built in there, so you can't enter any kind of bad data. Or another example might be in a particular box. A text box, for instance, might only allow you to put in numeric values. So if you try to put in, let's say, an alpha value, it'll error out. So you see these things all the time, especially now in various computer applications. All right. Yeah, so they, the other, and that kind of addresses that a little bit down on the bottom there when they talk about other prevention techniques and automated technology improvement and redesign. So the effectiveness has been proven. AT&T that actually won the Deming Prize. They reduced defects by 70%. So these are various example. Federal Mogul, 99.6% less customer defects and a substantial productivity increase. So not only do you gain goodwill from the customer, you reduce costs and increase productivity. So with mistake-proofing return on investment, maybe your projects, maybe that's how you're going to, in your projects, come up with your return on investment. So here they reported a Dana Corporation, a $500,000 saving resulted from a $6 device. That's a pretty good ROI. If you could come up with an ROI like that for your organization, I guarantee you'll be a hero. Hold on one second. I've got to take this call. Hang on. Hello? Yeah, I'm teaching. Okay, everything okay? Okay. All right, bye. I apologize for that. My father-in-law is sick, and my wife just called, but she forgot I was teaching. But I wanted to make sure everything was okay. My apologies for that. Anyway, yeah. So basically, for in some cases for very little investment, mistake proofing can really have a great return on investment. And I bet you that that $6 device, it was probably from one of the frontline employees, and like the one from Johnson & Johnson, that saved $75,000 by discovering a new use of Post-it notes. So you never know, but and a lot of times these ideas may already be there in your organization. And we talked about the 7 wastes, and the 8th waste being people. By really engaging your people, you may be able to come up with some really good mistake proofing methodologies that will decrease costs, reduce defects, and have a positive ROI and increase profits in your in your customer base. So errors cause defects. There are many different types of sources: human and error, process and human. A positive mindset, having a good attitude goes a long way in mistake proofing, and really getting empowering your employees and getting them engaged, I think really helps also. So next we're going to talk about Kaizen, and I will be back in 1 minute. Okay, so why Kaizen? And most of you had the Kaizen bursts in your value stream maps. So what is Kaizen? Another Japanese word. Kai means change, and Zen means good for the better. So change for the better. So it's it's gradual, orderly, and continuous improvement. And the important thing is it involves everybody. If it's not, it can't be just a top-down thing. It's got to involve all levels of the organization in order for it to be successful. So it involves a fundamental shift in functional management thinking. So the tradition, perception of job function, it was basically top management, middle management, supervisors, and workers. You had improvement was basically dictated by upper management, and the workers were responsible for the maintenance, and that was really it. And in a lean organization, top management encourages innovation, and of course there's still the maintenance piece of it, but you have the Kaizen, which involves the workers and also top management. It's given support by from top management, so it's got to be ingrained in the culture of the organization. So so basically. There's a set of concepts and philosophies on how Kaizen events are conducted, and it's important that those who do the work and not the supervisors and managers do the bulk of the Kaizen. So it's got to be from the bottom, really from the bottom up. So what are some of the benefits or the importance of Kaizen? In a lean environment, it improves lead time, process time, and cycle time. Everybody's looking. If you can accomplish those three things, you'll be on the road to a successful project. Transition responsibility for performance to workers, kind of a worker empowerment, and ultimately improves customer satisfaction, scheduling, competitive price point. It's just making it easy to do business with. And it helps the business. It can reduce cost, increase worker morale, reduce frustration, and it gains work commitment to do the work because you're getting empowerment and you're getting the frontline employees involved. So these are the basic ways that we learned from day one in this course. Okay, so and that's what Kaizen focuses on. So there's different ways, and I'm of doing Kaizen events, but this is one model where of course you identify the customer and then use the Deming cycle: plan, do, check, act. And I'll talk about this in a few minutes. We used to do Kaizen events, but we actually use the DMAIC model to do Kaizen events. So it doesn't necessarily have to be the plan, do, check, act. It can also be done using what we're using for your projects, the DMAIC model. In fact, let me run to that real quick. So we used to. This is not in your. Yeah. So basically, we used to do Kaizen events. They were like DMAIC projects, but instead of them taking 3 to 4 months, they were actually accomplished in weeks. So what we used to do was we would have about a month of preparation before a Kaizen event. So basically, we would have a month of preparation, and then we would actually have the entire team for a week. I mean, we'd be in a meeting room for 1 week, actually going through the DMAIC process, and then at the end, we had a post Kaizen follow-up checklist. So basically, this particular sheet, and I've also uploaded this on the supplemental materials if anybody wants to download it. This was a Kaizen planning checklist for the Transportation Security Agency purchase order process. So these are all the steps that we had to do before we actually did the Kaizen event. So really, the heart of the Kaizen event was a 1 week intensive DMAIC process improvement event. So we had to do a lot of the things, determine the focus, do a charter. We wanted at least 1/3 of the participants involved in the project. I mean, we had to get commitment from management to allow these employees to spend, a whole week away from their world of work to do all this. We had to do the SIPOC, kind of like, what you've been doing from the define phase. We had to collect data and then come up with an improvement event schedule and all this. And then, like I said, we would spend a week going through the entire cycle. And then at the end, we would come up with recommendations for improvement, and then we would have an out brief with our senior leadership. So at the end, we also had a follow-up checklist of different things that we had to do at the end to make sure everything was implemented. And there were, usually there was still some outstanding tasks that were left over, but. So we usually got these done. Like I said, was usually up to 30 days prep time, 1 week for the actual process improvement event, and then maybe a month or so of follow-up. And we found these to be much more effective than some of these long, drawn-out process improvement events. So it's something to think about. We call them Kaizen or rapid improvement projects, and we had a lot more success with those. So I wanted to point that out. And like I said, the checklists are under supplemental materials. If you find any value in it, feel free to download it and modify it. So yeah, so Kaizen, it's a total philosophy. You're teaching skills for problem solving. That's really, if you think about the, process improvement, whether you're talking about Lean Six Sigma, Kaizen, ISO 9000, TQM, it's all about problem solving and having a toolkit to resolve these problems. Develops effective teaming in small groups, because usually these Kaizen events are in small work groups. You don't want to cast the thousands. Too hard to manage. Hopefully, it can build future leaders that will sustain the system. It pushes consensus decision making downward, because it's those folks that are working in the process that are making a lot of the recommendation. Test the will of management, and if they're going to follow through on it, can help beat your business targets, and really it inculcates a culture of or an attitude towards continuous improvement. And that's the key really with all these, is to really have an organization, to change a culture in an organization so that it does have a positive attitude towards continuous improvement. And that's probably the most it's probably one of the most difficult things in any organization, is to build a attitude towards continuous improvement. So, so in the key Kaizen philosophy, that problems are gems. Okay, that every organization has problems, and they provide opportunities for change. In fact, a lot of people don't call them problems; they call them opportunities. So, and basically, what they're saying is that they're actually creating waste. So you really have to identify the problem to be able to implement any kind of improvement. And so you identify the customer. We learned, value added is always determined from the customer's perspective. We learned about value added and non-value added. Who is the customer? You all went through that really at the beginning when you did your customer matrix. Every process should be focused on adding value to the customer. Definitely. If it's not adding value to the customer, then you have to question it maybe through the 5 whys or through some other method. If it doesn't add value, it's waste. Now, of course, in some cases, it may be what we call business value added, where it may be something that's mandatory. But generally speaking, if it doesn't add value, it's waste, and that's where you put on your weights glasses and go to work on trying to either eliminate it or reduce it. And that's what I'm talking about. Some non-value added activities is necessary waste, regulatory and legal. We called it business value added. They call it NVAR, but it's the same thing, where you because of regulatory legal requirements, you might be required to incorporate that in your process. So the 3 F's: fix parts, things that you need, get rid of everything else. Fix location. What needed is put exactly where it is needed at the right time, at the right place, and how much is needed for everything. So it's really about establishing the culture of continuous improvement. So the 3 GEN principles, Genja or Gemba, go to the workplace where the process activity is happening, and it's also called the Gemba walk, okay, where you go around and just observe the process firsthand, and then get the real facts. Genjutsu, gather the facts from the place of the actual site where the process is actually happening. You go down there and just really see what's going on without depending on some report or getting it through through the chain of command. Genpin or Genbutsu, we look at review the actual output as you seek the facts in place where an activities happen. So you have to it involves careful observation, so you learn about your problems, what has to be improved, and what impact you can have. So, and these are some of the things you might observe on the floor there, on the manufacturing floor: eyes, hands, and legs not moving, buildup of material, machines, equipment and machines, I don't know about crying, but maybe stopping, and information has disappeared. Those are symptoms. And it's just a kind of a target process, or a target for each of the different steps in the process that can be used for a Kaizen rapid improvement. So we talk about the 5 whys, real good method for digging deep into finding the root causes. Okay, so actually they have 6 whys there, but it's generally called the 5 whys, and it's used to really drill down to get to the ultimate root cause of a problem. Yeah, so what you want to do is make improvements with what you have, not necessarily spend more money. Although, I mean, if you can spend $6, like you saw before, $6 and save $500,000, I don't think anybody's going to object to that. So basically, in a Kaizen events, by eliminating non-value-added activity, you should be also reducing costs, which will increase profits. And even in the non-profit world, it's money that can be reprogrammed to other uses. Okay. So the goal is try not to spend any money. Okay. Everybody contribute, especially the workers. You really can't run have a Kaizen environment or a Kaizen event without the frontline workers. Many times they've got the solutions. So standard approach. So basically, the benefits: simplifies training, increases quality, reducing waste, increases worker accountability. I think also worker empowerment, stabilize the process, makes process auditoring possible. It enhances continual improvement, and you provides meaningful performance metrics. So these are just different examples of tri-storming, where they try different things. So people are encouraged to experiment or model, and if it doesn't work, you don't get punished for it. Okay, so so it has to be an environment where innovation is encouraged, and if it fails, it's not you're not subject to punishment. Okay. So in Kaizen, it's important that things should be simple and fast, trial and error, one factor at a time, full factorial, fractional factorial, and others. And unrestricted input equals competitive advantage. So in moonshining, it's the rapid prototyping, trial, and the creation of new processes that give the organization an advantage that the competition can't touch, see, or begin to envision. Working smarter, not versus not working harder. So basically, be creative, get the new process in place, utilize what exists to implement the new process quickly, use mock-ups and temporary fixtures where possible. Permanent equipment could be added as a follow-up activity, and use signed-off policies and procedure. So quick and crude is sometimes better than slow and fancy. So try it, see if it works. Might involve running a pilot, which some of you may do in your projects before implementation. Running a pilot. It may not be perfect the first time, but that's where you have continuous improvement. You may not get a home run, but sometimes several base hits will get the job done. And if it isn't better, try again. And if it doesn't work, go back to the original process. In other words, you have to have an organization that's willing to try different things, and if it doesn't work, you're not subject to punishment. In fact, we used to call doing these things taking what we called reasoned risks. And that's just mistake proofing. We talked about that before. And that's it. Questions about anything we've covered today or in the previous lessons? All right, that's all I've got. So like I said, if you have any outstanding assignments, get them into me ASAP. Jay, if you hang on, I will double check for you about that assignment. Otherwise, like to wish everybody the best of luck going forward. About 3 more months, and you'll have your master's degree, and want to wish everybody, a good holiday season, and like I said, best of luck to you in going the rest of the way, and best of luck to you in your professional endeavors. So that's all I've got. Go forth and hopefully we'll see the results of your projects.
Happy holidays, sir.
Thank you. You too.
Thank you, sir, for that class. Hope you have a good one.
Okay. Thank you. Let me check. All right, Jay, I'm going to check on this.
Okay.
Give me 1 second. Let's see, stop. The code for this class is 794. That's 794.